Welcome to Vision Class and welcome back to this Singapore Mathematics. We are looking at the length of the tangent to a circle. Example 2 says that find the length of the tangents from the given points to the following circles. So we have the point from where the tangent is drawn to the circle and the equation of the circle. So part A, we are given equation x squared plus y squared plus 6x minus 4y minus 3 equals to 0. This is the equation of the circle, and the tangent is coming from the point 5, 1. So let us draw the circle, and then we draw the tangent which is coming from point 5, 1. I'm going to call this point B, where the tangent is coming, to make our calculation easier. Here we have the center, and this is the radius of the circle. Use a ruler which makes 90 degrees with the tangent. We need to find the coordinates of the center and the radius. They are going to help us in finding the length of the tangent. So the coordinates of the center C, we can get them from the given equation, and we have learned how we can get the coordinates of the center from the expanded equation of the circle. So in this case, the coordinates of the center are -3 and +2. And then what about the radius r? The radius r is the distance from C, the center, up to this point in the circumference where the tangent touches the circle. So let me call this point A. How do we get the radius? We know if you have the expanded equation of the circle, you can find the radius. How? Because we know that C is given by A squared plus B squared minus R squared. Where is C? C is this constant, -3. So -3 equals to A. A is -3, which is the coordinate of the center, squared, plus B. B is 2 squared minus R squared. That is what we did. So let us get the value of R. -3 squared plus 2 squared, -3 squared plus 2 squared plus 3. So I'm getting R is 4 units. R is 4 units. We should be able to get the same value of radius. So this is 4 units. Now we know the distance from C to A. And we are looking for this length, which is the length AB. That is the length of the tangent. So for us to get that, we must know the distance from the center up to that point B, where the tangent comes. So we are going to find the distance CB to help us in finding the distance AB. So the distance of the length CB, that is just the distance between 2 points. That is the point of the coordinate and the point where the tangent comes. So this is my x1, I'm calling this my y1, calling this my x2, this is my y2. And then I substitute for them in the equation for the length of the line, y2 minus y1. You must be familiar with this equation now. You must know that in your head. Now substituting for x2, which is 5 minus -3 squared plus y2 is 1 minus 2 but squared. This gives us the length CB. 5 minus -3 squared plus 5 minus -3 squared plus 1 minus 2 squared. I'm getting root of 65 units. That is the length CB. This length is root of 65 units. So since we know the length CA and the length CB, we can find the length AB from Pythagoras theorem. So applying Pythagoras theorem, we shall say AB squared plus AC squared equals to CB squared. That means our AB squared becomes equal to, what is CB? CB is root of 65, but we're squaring it, plus, now we shall say minus AC squared minus AC squared, which becomes 4 squared. Therefore, our length AB becomes root of 65 squared minus 4 squared under root, I'm getting 7 units. Just work out AB. Therefore, the length of the tangent is 7 units. This is the length AB that we are getting as 7 units. So that is the solution to part A. Let us go to part B. Part B, we are given the equation x squared plus y squared minus 4x minus 6y plus 9 equals to 0. And this is the point where the tangent comes. So we are going to say this is our circle, this is our tangent. You can draw it in any way. Let me say that is point B, where the tangent originates. Then we have the center of the circle here, and this is now the radius, making 90 degrees with the tangent. So I'm going to call this point A, and then the center. What are the coordinates of the center? Since we have the equation, we can get the coordinates of the center, which are in this case 2 and 3. And now we are left with getting the radius of the circle. Since we have the expanded equation, we know that C is given by A squared plus B squared minus R squared. The C is not the center, okay? The C is the constant, is the sum of constants, which is positive 9 in this case. Therefore, 9 equals to, what is A? A and B are coordinates of the center. So we shall have here 2 squared plus B is A squared minus R squared. And then we look for R. So we make R the subject. 2 squared plus 3 squared minus 9. So my R is 2 units. So now the radius here is 2 units. So after getting the radius 2 units, we now know this distance from here to here. We don't know the length AB, that is what we are looking for. But we can get the length CB and then we apply Pythagoras theorem. So let me join these 2 points here. I say that is my length CB. So let us get CB to help us find the length AB. So CB is going to be the length between 2 points. So this is the first point x1, y1. The second point is x2, y2. So the length CB becomes the square root of x2 minus x1. That is the formula. Plus y2 minus y1 squared. And then we substitute x2 is 5. Gives us the square root of 5 minus x1 is 2 squared plus y2 is 7 minus y1 is 3 squared. Then you put the calculator. 5 minus 2 squared plus 7 minus 3 squared. So the length CB here is 5 units after taking the square root. So this length CB here is 5 units. Since we know the distance from A to C to B, we can apply Pythagoras theorem to find the length AB. So we just say applying Pythagoras theorem, which states that AB squared plus AC squared equals to CB squared. Okay, this formula depends on how you have put your points A, B, and C. As long as you are equating to the length of the longest side, it is correct. So we substitute. We are looking for AB, so there's no value for it, plus AC. AC is the radius, which is 2 r squared, equals to CB. CB is 5 squared. That means our AB here is going to be 5 squared minus 2 squared under root. I'm getting root of 21. Getting root of 21 units. That is the length AB. Therefore, the length of the tangent is root of 21 units. So that is how we solve part B, and this is the overall solution to example 2.